Hello, STEM Nation. Jeff here, and welcome to episode number 1 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math. Let's start by thanking our sponsor, Audible, who is offering a free audiobook at stemonfirebook.com. Go to stemonfirebook.com to get your free audiobook. If you're looking for a good book to listen to, I would recommend The 7 Habits of Highly Effective People by Stephen Covey. Let's get fired up today with our guest, Mike, and I hope our chat today will help ignite your passion towards a STEM career. Mike Gilling is a 2017 graduate of the University of Wisconsin-Platteville with a Bachelor of Science degree in Mechanical Engineering and was heavily involved in the SAE formula team throughout college. Also during college, he was a mechanical engineering co-op and intern at Husco International, and upon graduation, Mike took a full-time position at Husco in the mechanical engineering design department. Welcome to the show, Mike. Take a moment to fill in any gaps and share a bit of your personal life.
Hey, Jeff. Thanks for having me on. You did a good job explaining my college career and the future from there. I started my engineering career kind of back in high school with the first robotics competition, which basically you build a robot and compete, and that was kind of my first touch on engineering, and then progressed there, like you said, to Formula SAE and some co-ops internships at various locations, and now I'm full-time.
Excellent. Hey, thanks for filling that in a little bit. So let's get right into it. So for somebody not familiar with mechanical engineering, and I think most people are familiar with mechanical engineering, but for somebody that's not, can you give some examples of career opportunities, and then we'll delve into your area of specific expertise?
Sure. So the area of mechanical engineering, mechanical specifically, and some others as well, is extremely broad. If you think about it, kind of everything that's around you, anything that's been made by a person, with exceptions of a few couple things here, an engineer's worked on it and designed it and decided, why we put this material here or this shape or something. So there's so many different options you can pick, which is why I went for mechanical engineering, because it's so broad. And so you can do things like me, work with hydraulics. You can work in the automotive sector, electronics, various things. There's a huge amount of opportunity available, and the amount of jobs available right now is staggering. I get calls probably every month from recruiters and companies talking about their jobs that are available and trying to get me to be interested in their jobs.
Yeah, that sounds like there's a good market out there for mechanical engineers, so it sounds like that was a good career choice for you. So let's dig in now into your specific area of expertise.
Sure. So right now, as you said earlier, I'm working at Husco International. I'm a design engineer there, and Husco International is a company that designs hydraulic valves for the off-highway market, so excavators, dozers, forklifts, lots of different things. And so within my group, I work a lot on FEA and CFD projects, as well as some application stuff, working with customers, working with different suppliers to get our projects moving and get the parts made. So,
hey, you mentioned a couple of acronyms, FAE or FEA. Can you explain what those are?
Sure. So CFD is computational fluid dynamics. That's it's kind of simulating how fluid flows through a system. So in my case, it's through a valve, and we'll look at different things like pressure drop from one port to another, or flow forces across something, or things like that. And FEA is kind of the mechanical or structural side of it, where you look at the stresses that a force puts onto a material or a part of some sort.
Yeah. Hey, thanks for filling those acronyms. I know there's a lot of acronyms out in the world, and when we use them, hopefully we can define what those are to help our STEM nation figure out what's going on.
There certainly are a lot of acronyms. In fact, Husco's got a whole book full of acronyms to get people up to speed. You start understanding them over time, but it takes a bit to catch on for sure. Yeah,
it can be overwhelming at first.
Yep.
So, going from college into the work world, what does a typical work day look like for you, or a work week look like? What can a new professional expect in the real world?
I would say time-wise, it's very similar to college. 40 hours a week is roughly the amount of time I spent at school. But the difference is it's regular hours. I get into work every day about 7 or 7:30. Check my emails, start working on my projects. And like I said, those vary from CFD and FEA analysis, writing reports, doing testing on machines, actually creating test plans, various different things like that. And while I'm doing this, I'm collaborating with people in the U.S., different states, and different countries like India, China, England, various different places like that. So a lot of communication and a lot of different projects, a lot of variety at work. So
Yeah, I think STEM Nation, most of the companies you're going to work for are going to be global companies, and those communication skills are very, very important, so start learning those now.
Yeah, hugely important. The communication skills now more than ever probably are a huge deal.
Yes, I agree. So, Mike, let's get specific here. What is one thing that has you fired up about mechanical engineering, and where do you see the field headed?
So mechanical engineering is super broad, and I follow a lot of different kind of aspects. I'm big into racing, lots of different things. One thing that's got me really kind of interested more recently is kind of the advanced prosthetics and body augmentation systems that have been coming out. Some electromechanical systems that have been integrated with people, sensors on the muscles and stuff like that to give them an arm back if they lose it, or a leg or something like that. And so that's pretty interesting to me. The ability to help people and get their function back after such a traumatic experience is great. And then there's other applications like the military, or in places where someone needs to lift a really heavy object or carry something for a long distance or something is pretty cool to me.
Yeah, and I think that would also involve probably like biomedical engineering or something around that field, along with the electrical and computer engineers.
Oh yeah, for sure. It really kind of combines all of the degrees. Like you said, you got to have the biomedical to interface with the human, and then electrical to decode those signals, and mechanical to make sure it's strong enough and it's built and it's comfortable. It's really kind of an interesting area.
Yeah, a multidisciplinary approach.
Yep.
All right, Mike, so changing gears here, let's move into a story, an aha moment you've had, something that might help our STEM nation. Can you take us to a moment in time of an incredible aha moment you've had at work or your personal life, and tell us the story and how you turn that aha moment into success?
Sure. So thinking back on it, it's hard to pick one moment that was kind of very influential. But if I had to pick one, and this kind of more or less happens all the time for me, but back in high school, I've been riding motocross a lot, doing off-road riding, and I needed to adjust the suspension on my dirt bike at the time. And the tool I had for it didn't quite work, didn't fit perfectly. So instead of just going out and buying a new tool, I actually cut the tool apart, welded it up kind of differently, welded a socket onto it so I could kind of change the angle and stuff, and made this adjustment tool that worked for me, and it was adjustable. And after using it, I saw some kind of benefit over the stock tool. So I talked to a few suppliers, some manufacturers, and got a bunch made, and have been selling them ever since. So that was kind of my first full project of engineering, you could say, where I brought it from an idea to a final product. So that was kind of my aha moment, and brought me into engineering, kind of set the plan in stone, or you could say.
And that was in high school you were doing that?
Yeah, that was, I would say, junior or senior year of high school. That's when I did that.
So were you able to get tools online that allowed you to do that mechanical type design, or did you just kind of draw it up by hand?
Yeah, so back in high school, like I said, I was in the first robotics team, so I'd been using Autodesk Inventor for 3D modeling design, and so I was pretty comfortable with that. Had a copy myself, and used that to kind of refine my design a little bit more and make it easier to manufacture, and then made some drawings up and gave those around to different manufacturers.
Yeah, that's pretty fantastic. I mean, being an entrepreneur in the high school world, and then taking that into forming your mechanical engineering career, and then now a full-time engineer. So that's really cool.
And it's not so much that I made a lot of money off this, or it's been this great success. I actually haven't made very much off of it. But the thing is taking the initiative to think of an idea and then see it all the way through. And to be honest, I think this project has gotten me a couple jobs over the course of my life. Companies see that initiative, they see the success, they like that kind of stuff. So that I think it's helped me a lot.
Yeah, and I think the companies out there, they look for people with initiative, with that stick-to-itiveness, possibly even over grades. Personally, I would take somebody with the drive over grades any day, because I can always teach them what they need to be taught, but I can't teach somebody drive. And that's awesome that you have that drive, Michael. Yeah,
I agree. I think the initiative is almost more important than grades a lot of times, and I agree that companies look for that, and they definitely give it a heavier weight than grades at some point in time. I'm not going to try to tout that I was this great student in college and stuff, because I didn't get the best grades in the world, but I do have a very good job and had probably a good career coming up here. So
for STEM Nation, if you're in college, you're heading off to college, and you don't have straight A's, don't worry. Just have that drive, do extracurricular activities like the SAE, do some things on the side, and just be creative, and the doors will open up for you.
Yeah, definitely. Taking the opportunity you can to be creative or do extra things, barring that you don't let your grades suffer too much. But,
yeah,
because those are a little bit important. But Extra is good for sure, and companies like to see that.
So I think that's a good segue. We're going to go into kind of the college life here. So we're going to transition into a topic that's probably on the minds of our STEM nation, especially the high school students that are wondering what it takes to get through college to be successful in these, I'll say, rigorous STEM curriculums. If you could go back in time, Mike, what would you tell your 18-year-old self as you're heading off to college? Some things that you wish you knew back then, or even knew back then, that would help our STEMers launch into college successfully?
Sure. So if I were to tell myself when I was 18, the biggest thing I would tell myself is to take more risks. And I'm not talking about jumping off bridges or doing things that are dangerous and risky, but just doing things that push the limit of my comfort zone and are outside what maybe normally people would do, take more effort than people would do. And those little opportunities, you could say, like the shock adjustment tool that I made, have really helped me jump forward in my career past some of my other friends. So doing more of that, I think, would have been great. And I'd advise many people to do stuff like that. It's okay to take some risks sometimes, even if it's outside your comfort zone, and it'll pay off in the end. And if it doesn't, you can learn from the mistake, you can learn from what you did and move on with it.
I completely agree with that, Mike. You have to be constantly pushing outside of your comfort zone. If you're always in your comfort zone, you're not going to learn. And I'll say the most of the things that I've learned is because I failed at them. I learned from that failure and I adjusted, and you just become much more knowledgeable by just trying things, and hope you fail, because when you do fail, you're advancing.
Yeah, exactly. And never take a failure as a bad thing. Like you said, you learn from these failures, and some of the most notable things in history and in science have come from failure. Believe it or not, you got to learn from that stuff. It's extremely important to be able to learn from it and then move on and not get stuck on it. Don't dwell on stuff like that.
Yeah, don't dwell on the failures. Hey, Mike, are there any classes in high school that you took that helped you prepare for college, or some classes that you wish you maybe would have taken in high school?
Help me prepare for college. Maybe more math classes in college or in high school. When I started college, I was a little bit behind the curve for math. I would have liked to be in a different track, you could say, in high school, and end up in a higher end class at the end. It didn't hinder me too much. One thing that I think is good that engineers should be able to do is don't be afraid to get your hands dirty and to work on things and see how they work, take them apart, look at it. That's when I was little, I used to take stuff apart all the time and drove my parents nuts, and I would eventually put it back together, but maybe it didn't work so great at the end. But I'd still learn how it worked and see how it functioned. And so in high school, I took pretty much every shop class I could to be able to see how things are made and see how they work together and why we do things in certain ways. And to know how things are made and how they work is extremely important, because I can design some really great products, but you can't manufacture them. And if you can't manufacture it, you can't sell it. So having that little inkling is pretty important.
Yeah, that's some great insight, Mike. Appreciate that. We're going to turn our attention into what skills or attributes do you think are needed for STEMers to be successful as they transition from college into their careers?
Yeah, so I want to take a step back first before we go to transitioning from college into careers. During college, I think one hugely important thing is to take an internship or co-op. It's an unbelievably invaluable event. Not only are you going to get paid for it, but you're also going to get some extremely, extremely good education and learning at these places. And as a bonus, places are getting almost free training for you, and they'll probably give you an offer for full time when you're done, which is what happened with me at Husco. And so taking that time before you graduate to do the internship, to do the co-op, even if you have to take a semester off, I think is extremely important. To start the full-time job, you'll have all the skills that you need from college, but to continue through that, you have to keep learning. You can't stop, because if you stop learning right when you graduate college, you're going to get stuck. You're never going to move on from there. And for some people, that's okay. If you want to move forward and you want to be really successful in your career, you can't stop learning. You got to take every opportunity you can to learn more, to continue it, and that'll lead you to be a very successful engineer.
Yeah, it's a lifelong learning adventure. I've been doing this for about 30 years, and I don't think there's a day that goes by where I don't learn something new. And that's what keeps this type of career exciting, is always learning something new. I want to go back and just define what the difference between an intern and a co-op. So
Sure.
An internship is pretty much a summer job. So between, when you get done in the spring and you go back in the fall, you take that summer, and that's called an internship. What Mike is describing as a co-op is when you actually take a summer and a semester off of school and you work for around 8 months. And you can really delve into a project and get a lot of great experience through the co-op program. So look into the co-op program if you haven't out in college, and take advantage of that.
Yep. And a lot of times the co-ops you can get credit for in college, and some colleges even require them. But I'd look at it more as a extremely good learning opportunity. And like you said, you can get a lot deeper into a project than you can in an internship. There's a lot more time involved, and you get paid more too. So that's good.
Absolutely. Pay for that college tuition. It's not going down.
Exactly.
So if we can go now to the skills and attributes that you think are needed for STEMers as they go from college to their careers, what do you think they need?
Skills, the drive to try new things. I'd say question all of the stuff that you see. Don't. It's tough to say question everything, but don't challenge everybody about their stuff. But it's okay to say, okay, why do we do it this way, or why can't we do it this other way? Because you learn from that a little bit. So I guess one skill that I'd say definitely to be aware of is question every little bit and learn as much as you can from the projects you're working on, and then apply that learning to the new project or the next homework that you have to do or something like that.
Yeah, that's good advice. All right, Mike, hey, are you ready for the lightning round?
Yeah, let's do it.
All right. What's the best piece of advice you've ever received?
I'd say the best piece of advice I've ever received, and it sounds maybe kind of cliche, is to just stick with it and don't give up. There was a time when I was in college that I was having a really tough time. The grades weren't perfect. I wasn't really having a hard time, and I was going to switch degrees, and talked to a few people, and they told me just to stick with it, and I ended up being able to graduate and got good grades after that. It was fine. I have a good job. And so stick with it. Don't give up. The stuff is going to be really hard. It's going to seem like you're not going to be able to get it done, but everybody does. So just keep sticking with it. It'll be worth it in the long run.
Yeah, stick with it, STEM Nation. And that's why we're doing this podcast, is when you're up late at night doing the homework, you can remember these podcasts and remember the advice that Mike gave you. Just stick with it. It'll be worth it in the end. I think these STEM careers are some of the best careers you can go after.
Oh, yeah.
So, Mike, what's a personal habit that contributes to your success?
So kind of like I mentioned earlier, I tend to question everything that I'm doing. So the other day, for example, I was working on a casting, a metal casting, and there's a lot of people there that have designed these castings for years, and they have this certain way that they do it. And, I wanted to do it a different way and try this new way to develop the casting. And, I showed it to them, and they said, no, we can't do that. And I just asked them, why can't we do it? What is holding us back from doing this? And after some conversation and some time, we found out there's not much holding us back from doing it. It's more so this is what we've done for so many years. So let's try this new way, and hopefully it'll turn out to be better. So you got to try those little things. And when you ask questions and you push the limit there, and you pick up little details over time, and those little details may seem insignificant at the time, but you pick up enough of those and it adds up to quite a bit of knowledge. And so to keep doing that is really important.
Absolutely. Hey, Mike, what is your favorite internet resource or phone app, and why?
My favorite app, we could say, not one in particular, but I like to keep an app that gives me a task list, something I can put stuff in and check off when I get them done. And it's right there on my phone every time I turn it on, so I see it all the time. I know what I got to do, when it's due, and then I can check it off right when I'm done. So that keeps me on track and make sure I get stuff done in time. And there's plenty of them out there. Just a huge number. So pick any one, get comfortable with it, and use it.
Yep, a task manager. I use a task manager myself, and it just keeps your brain focused on what you need to be working on. Hey, Mike, what is one book you recommend, and why?
So I don't do a whole lot of reading book-wise, but if I had to pick one book that I've read in the past, it's the book the autobiography or biography of Elon Musk. It's called Elon Musk, Tesla, SpaceX, and the Quest for a Fantastic Future. And it kind of follows him through his life when he grew up in Africa and South Africa. His, the troubles he had there, the risks he took, the things he did to get to where he is now. It's not so much like you're going to learn so much from this book. More so it gives you kind of the idea of the light at the end of the tunnel. And people just like us have grown up to be extremely successful people in the world, and it helps reinforce that all of this very difficult and challenging work is worth it in the long run, and you're going to make it through it, and you're going to be successful. And so I like that book quite a bit.
Yeah, I think that's a great recommendation. I think part of it, people look and go, well, Elon Musk, I mean, that it's because that's why he's so successful. But what you don't see is all the grind, all the work he put into it before he became successful. So there's so much work that goes into these people that are successful. So find some books like that, some autobiographies, and see what these people did to be successful. Hey, Mike, we're going to wrap it up here. So as we wrap up, can you share a parting piece of guidance for STEM Nation? And then we'll say goodbye.
Yeah, so I guess a good parting piece of guidance is to say the most important things you can learn as a young engineer or an entry-level engineer is learn to communicate with everybody else. Like we said earlier, you're going to be working in a global company, most likely. Being able to send emails right or talk to people in person is extremely important, and to be able to convey your point or your ideas to them is going to help you a whole lot. And then also, as we mentioned earlier, turn those mistakes into learning experiences. Don't dwell on them. If you make a mistake, take a step back, look at it, see, okay, what did I do here? Where did it go wrong? Why did it go wrong? Remember that and move on. If you dwell on it, you're not going to get anywhere. And if you note it and then move on, you can use it in the future and you'll be more successful because of it.
All right, Mike, thank you for that parting piece of guidance. And with that, we'll say goodbye.
Thanks, Jeff. We'll talk to you later.
I hope you enjoyed our discussion today with Mike. Head over to STEMonfire.com for more information and tune in next week where we interview Aaron, a computer engineer. Until next time, I hope this chat has helped ignite your passion